4. Find the medians of 3-element array and a 4-element array. In the last video of part E, I want to solve two relatively simple selection problems. Yeah. All right. The first one, so let's find the median of a 3-element array. Yeah. This one should be pretty easy, right? Yeah. So the 3-element array, we can use x1, x2, x3. All right. x1, x2, and x3. Yeah. We want to find the one in the middle. This one cannot be the minimum and cannot be the maximum. All right? Yeah. The one right in the middle. And we want to use the minimum number of comparisons. Okay, all right. Because we only have 3 elements, so we can do it easily, right? The worst thing the slowest thing we can do, we sort the array first. Then we just pick the median easily, right? First, let's look at if we sort it. If we sort it, how many comparisons do we need? How many comparisons do we need if we just sort it? Yeah. Here, although there are different ways, you can try different ways, but here I may like to go to the insertion sort. Insertion sort. All right, so we can see how many comparisons do we need, right? For the insertion sort, the first comparison, x1 and x2, we do comparison. Suppose we get it sorted like x1 first, then x2 second. All right. Step 2, we do insertion, x1, x2. We do insertion x3, insert into somewhere in the array, the worst case. Here we consider the worst case. Yeah. So let's assume x3, x1, x2. Worst case, we needed 2 more comparison, right? Yeah. 1 comparison here, 2 more. So the total, 1 plus 2. 3 comparison, we can get it sorted. So here, for this question, the worst answer is 3. Okay? The bottom line, we can use at the most 3 comparison to solve it. All right, yeah. But you may like to try if you can use 2 comparisons to find the median. Is it possible if you try, you cannot make it? Yeah, 2 comparison. Yeah. For example, so let us try a little bit. All right, so let's try if we can use 2 comparisons. First, we compare x1 and x2. We need to do comparison, right? x1, x2, we need to do comparison. Okay, yeah. After this comparison, without loss of generality, we can assume x1 less than x2. All right. After that, x3, this time you have x3, the next comparison, either with x2 or with x1, right? You do either comparison with x2 or x1. Yeah. All right. So if you compare x3, x2, and x3, you have 2 possibilities. x2 less than x3 and x2 greater than x3, right? Now, x2 less than x3, you'll find a median. Median is x2. Median is x2. Yeah. 2 comparison, You can find the median. But when x2 greater than x3, what is the median? So here you have x2 greater than x1 and x3. So in this case, you need another comparison, x1 and x3. The larger one will be the median. The larger one will be the median. So the larger one will be the median. But this case, you need 3 comparisons. And we want to use the worst case. We want to use the worst case. So we want to use this answer, worst case, 3 comparisons. So that means even you just want to get a median, you do not need to sort it, but you need 3 comparisons. You need 3 comparisons, the same as the sorting number for 3-element array. For 3-element array, the answer is 3 comparisons. Finding the median, you need 3 comparisons. All right? Yes. All right. Next problem. Yeah. Find the median of 4-element array. All right. This time, it is much harder than the first one. Yeah. Given 4-element array. 4-element array. The median, so what is median? Yeah. 4 element, you have 4 elements. The median, by default, we mean left median, right? Left median. Left median means the second smallest element. So here, in 4-element array, it means second smallest element. So given 4-element array, we need to find second smallest element. How about that? Second smallest element, not the first smallest element. Second smallest element. Yeah. Here, let me use that trick. Yeah, that special way to solve it. Okay. All right. First, let us group these 4 elements in 2 pairs. Pair 1, x1 and x2, we do comparison. Pair 2, x3 and x4, we do comparison. All right. We assume the winner is x1. Here, winner is x3. Yeah. Winner here, we mean x1 less than x2. How about that? The winner, we mean x3 less than x4. How about that? All right. Then we do another comparison. x1 and x3, suppose winner is x1. So x1 is the smallest. After 3 comparison, 1, 2, 3. Yeah, because it's the winner. This is the smallest. All right. It is smallest, but our goal, second smallest. Not smallest, second smallest. That means we want to find 1. We want to find 1 from x2, x3, and x4, the largest in, we can say the largest in not largest, the smallest, right? Because second smallest, right? So we take away the smallest. Smallest is gone, all right? So now the next smallest, not largest, the smallest in x2, x3, x4. How about that? Okay, the smallest. Yeah. All right. But here we already know x4 greater than x3, right? So x4 cannot be the candidate. How about x4 cannot be the candidate of the smallest in 3, remaining 3. Okay, so we can cross out x4. Only x2, x3 left. x2 can be a candidate and x3 can be a candidate. So let us just do x2 and x3 to do one comparison, and the smaller one will be the answer or solution. How about that? But you need a fourth comparison, right? You need another comparison to find the second smallest. So finally, the answer for this question, find the median of 4 elements, you need 4 comparisons. 4 comparisons. Yeah. All right. A little tricky than the previous one, but I think you can handle it. You can handle the computation like this. Yeah. All right, so let us finish all the examples in part A.